So far, the only type of series that we've talked about is a geometric series, and we know it converges if the absolute value of r is less than 1. But we also want to look at other types of series and see whether it converges or not. That means if I add up all the numbers infinitely, does it get to a sum or not? Now, based on what we learned in the geometric series, we know the only way it can converge is if all the numbers are getting smaller. That's why that absolute value of r has to be less than 1. If those numbers are getting bigger and we add it up infinitely, obviously the sum is going to just go to infinity. And this is what this NthTerm test for divergence tell us, and it works for a geometric or for any type of series. If the limit of that general term does not go to 0, so those numbers are not getting smaller, then we can say for sure that that series, the sum of those numbers, is going to diverge. It doesn't approach a sum. Now, if those numbers do get smaller, this is just going to tell us that we're not sure whether it approaches a sum or not. For right now, we're going to say it's inconclusive. Later on, we'll find some other tests that will help us figure it out. Okay, so for right now, we have two things we can do. We can see if it's geometric. If it's not geometric, we can use this NthTerm test to see if it diverges or not. So first one, I know it's a geometric because I have a number raised to the nth power. Your r is 2. If r is 2, then we know it diverges because those numbers are getting bigger. Okay, number 2 is not a geometric series. I don't have a number raised to the nth power. If you look at this list of numbers, if I plug in 1, your first term is 1, your next term is 1/2, 1/3, etc. Okay? So this is not a geometric because you're not multiplying by the same number every single time. So we're going to have to use this NthTerm test for divergence. And let's see what it says. If I take the limit as n goes to infinity of that general term, it is 0. So these numbers are getting smaller, which we can see. But this test just does not tell us whether it converges or diverges. So we would say that's inconclusive, or we would say it's more info needed for right now. Okay, number 3. Again, this is not a geometric, so we're going to use the NthTerm test. So we're going to take the limit of this general term, and behaves very similar to when we have polynomials on the top and the bottom. In the long run, these factorials are going to end up canceling out, so it's basically the ratio of the lead coefficients idea again. Now this limit is not 1/2, which is not equal to 0, so we know for sure that this series is going to diverge. Try the next 5, pause the video, and then come back and check your answers. Okay, number 4, I'm going to use the NthTerm test here as well. If I take the limit of this limit is 1/5, which is not 0, so I can say for sure that it's not going to diverge. Okay, number 5, this is a geometric series. The only thing that's being raised to the nth power is the 3, so your r is really 1/3. That is less than 1, so we know that it converges. Okay, number 6, we're going to use the NthTerm test here. I'm going to take the limit as n goes to infinity of n over ln of n. Now, when you plug in infinity, you will get infinity over infinity. So you can do L'Hopital's rule if you want, or when you're talking about the same function, taking the log of that function slows down that growth. So the top is going to grow at a faster rate. So I know this limit is infinity, again, which is not 0, so I can say it diverges for sure. If you want to use L'Hopital's rule, that's fine. I get infinity over infinity, so I would take the derivative of the top, derivative of the bottom, simplify this though, which really is n, and notice this limit is infinity, same thing that we got there. Okay, number 7, again, I'm going to be using the NthTerm test. Limit of the term is ratio of the lead coefficient is 1/2, not 0, so we say it diverges. Last one here, the top part is geometric because you do have a number raised to the nth, but the bottom part is not, so the whole thing is not a geometric, so we'll use the NthTerm test again. Take the limit. Again, when you plug in infinity, you do get infinity over infinity. You can do L'Hopital's rule twice if you need to, but this is an exponential, this is a polynomial. Exponentials always grow faster in the long run, so this limit is infinity, which is not 0. So we would say this also diverges. So the nth term test can only tell you if it diverges. Your conclusion should never be convergence from the nth term test.